now I'm going to go over the code. This is the updated version, not to be confused with a couple earlier videos that had a different version. Anyways, there's some comments up here that can help you get started. I also have a video that you can watch on setting up the IDE for Arduino. You basically have to copy this link so that you can get the libraries. You have to use that link. Alright, so here is actually one of the libraries that is used. It does not come standard with the Arduino. I'm just going to try and go down the code here and give you a brief explanation of what's going on. Alright, so in debug mode, basically that's going to turn the serial port on and allow writing to the serial port. I currently have it turned off because I was just testing a pretty high click per minute object. And unfortunately, if you do that, it's going to try and send serial data every time there's a count. And if you have a lot of counts per minute, it's just going to overflow the buffer. So I had this set on false, but I'm going to go ahead and turn it to true later on to show you the serial output. Alright, max chart elements is the number of elements to display on the graph. If you set this too high, the page is going to take a little time to load, just because 60 elements sent to Google and back it's just going to take a little while. Plus, it's going to have to read all those lines out and print them out to the client, which also takes time. And your Wi-Fi SSID, password, interrupt pin. This is the pin that is connected to the LED. And the max number of file lines, I chose 1440, which is 24 hours of data lines. And the maximum number of files I set to 45. You can change these values if you want to make adjustments. You could go higher than this. I just wanted to put a limit in there because if you just continuously create files, eventually you're just going to run out of space and crash the program. And we got some more variables here that are used throughout the application. Some of them should be pretty straightforward. Alright, let's get down to this first function here. Now before we write the setup and the loop function, we're going to have to write any other functions that we're going to be using in those. And this is a function I call pin change, and this is based on interrupt. So I'm attaching an interrupt to the pin that's connected to the LED, and it is going to be actually, this is detaching the interrupt. I'll be attaching the interrupt for the first time in the setup. But when you actually run the function that is performing the interrupt action, you want to detach it. Otherwise, it's going to try and run this thing more than once and you're going to crash. Alright, so you detach your interrupt, do your processing, and then reattach the interrupt. And this is set for rising. So anytime the voltage rises, it's going to execute pin changed. That's basically where the counting is done. All it's really doing is counting the clicks and excuse me. Alright, here's another little function called reset variables. I have a couple features in the application that require the variables to be reset. One is the reset session. The other would be when you go to the data files and you clear them. It's also going to reset those values. And also, every time it creates a new file, it's going to reset those values. Alright. Now we get down to the main setup routine, where right away we attach the interrupt. And that allows it to start counting right away. And we open our spiffs file and count the number of lines, count the number of files, and start filling up some of our variables so that they can be used. And get down here. It's basically checking for data files. If there are no data files, it's going to format the spiffs, and it's going to take about 30 seconds to do that. And we get down to connecting. Alright, so basically I wait for a while for it to connect. If it doesn't connect, we just move on, because we want this program to work without having to be connected to the internet, so that you can take it out to a remote spot, turn it on, and it'll just start storing up data. You know, of course, you're going to want to go out there before the maximum days is reached and collect it. Then you can bring it back into a place that does have Wi-Fi and examine and download the data. Alright. Just more serial information used for debugging. And we get down to the main loop function. Now this is where things kind of can get complicated. So first off, we're going to check to see if we've reached the max number of file lines. If we have, we're going to go ahead and create a new file, which basically just keeps the files storing up. Every 24 hours it's going to create a new file. And if we've reached our maximum number of files, then it's basically going to stop counting. So this is where we begin counting. So if our current minute is greater than our last minute, we are going to do a count. Well, not really a count. We're going to take the count that we have and we're going to write it to our spiffs file. So we open the file for append and write the data. So it's just going to write one line after another. And we'll update our line count. And now we're going to check to see if anyone's accessed the web server. Do we have a client that wants to view the web page? If we don't, we just get out of this whole thing and go back to waiting. But if we do, it's going to start processing. So it's starting to get some variables, the Wi-Fi strength, some more serial information. And this will be one of our first actions that can occur, called refresh. I'll take you back to the site here for a second. So if you hit this refresh button, what it's going to do is just do a page refresh. And then we also have the reset button, which you can see on the other page. That resets the session variables. And now we're going to actually start writing out to the client based on different actions. So one of the actions would be to clear the data. This would happen when you're on the data files page and you click the button to clear the data. It sends this and it says, oh, we've got a request to clear the data. So what it does is it goes through and deletes all the files that are stored up, and that allows you to start over. And then we're going to print out beginning of our page, kind of just showing that the files were cleared, and then they can click back and start monitoring again. And this is something that's going to happen if you reach the max number of files, because this is going to stop storing data. It'll retain the data that it already has, but it's not going to record any more. And I just kind of set it up that way on purpose. Alright, so come down here and we reach another function called GData. Now this is what happens when you actually click on one of the data files that you want to download. I'll give you an idea here. So we've got these data files. You can click on these and the code is going to interpret that as you want to download the file. So it, instead of sending you a web page, it's going to send it to you as a file, which will automatically start a download. And that's how that works. Alright, so now we're getting down to basically the main page. Main HTML page. I'll take it back there. And this is the message that's going to tell you if you've reached the max number of files. So it will at least tell you, hey, the data is full. Alright, yep, so the data is full. You have to do something about that. And we go back. So that's what happens when it receives data. So when you click on that link to go to the files page, it sees this and it prints out all the files. Oops, sorry. Alright, now this is really more the main page. I've got some of our variables. This is just sort of taking account, holding on to it, so these variables can be used throughout the page, because when this thing's counting real fast, these things are going to change. So you might have set a variable in your chart, but then when you display it later on in the page, it's different. So that can truly be confusing. So I set these holders to get around that problem. And here's just some of the Google JavaScript to set up the charts. Here's drawing one of the charts. Drawing the medium emissions gauge, high emissions gauge. We're getting our analog value from the battery or power source, basically. In our case, it's the ESP8266 that's powering the unit. It could be batteries, and then it would tell you what your battery level is. And this draws that main chart at the bottom, the sort of timeline. Alright, so that's pretty much all Google data that I took from their site and just inserted my own variables. Alright, so this is basically the HTML for the main page, and it's pretty straightforward. It just has a few links, some data showing the variables, and in the table it shows the different charts. And at the bottom, you got your Wi-Fi strength and your battery voltage. And these are just some variables, or you can uncomment this if you want to use this for debugging. It just shows you more information about the file system. And that's pretty much it. I will come back in 1 minute after I recompile this so that I can show you guys some of the serial data. Alright, so I'm back to show you the serial data. When I uploaded it, it doesn't want to connect sometimes, so I just unplug the USB, plug it back in. That usually fixes it. So we will see. Start the serial monitor again. And I do believe we are connected. I didn't get to see the message pop up. But it is counting. But it doesn't need to be connected to count. But we'll find out soon enough if this is connected. So I'm going to check out the web page. And I think we should be able to get to it. Yeah, it's got a client. It's reading from the SPIS file, and it continues to count anytime there's a hit. Client disconnected. So that's just showing you some serial data as the program is running. And this could be helpful for debugging, or if you want to change some of these variables around, this could be helpful in just to figure out what is actually going on. Reading from the SPIS file, writing to the SPIS file, so every minute it's going to write to the file. And whenever the client wants data, it's going to connect. So it refreshes every 60 seconds. And that's pretty much it.